Hello. One of the questions we often get asked is, how do I choose which would be the right camera for me from the 20 or so in the Atik camera range? So what we're going to do is look at some of the simple things that we can use to compare the different cameras to see how well they would suit your style of imaging and the telescope that you may have. So probably the first thing to look at is image scale. This is simply the pixel size in micrometers divided by the focal length in millimeters, multiplied by the magic number of 206. And the value you get there is the number of arc seconds per pixel. And this value should be in the range 1 to 2, ideally. If you find you have values of greater than 2, what that will indicate is that you are undersampling an image and the stars may start to appear blocky and square. This can be a problem, or you can get around it by slightly smoothing the images afterwards, but in an ideal situation you would either go for a smaller pixel size in that situation or a longer telescope. The other situation that maybe you're more likely to come across is if the number comes out to be less than 1, and that's indicating that we're oversampling the image, and there we're indicating that the image will have large or bloated stars and that tracking will become more difficult. And that's given when you have a small pixel size and a long focal length. So here, to rectify that situation, we either need to consider a camera with a bigger pixel size or introducing something like a focal reducer into the imaging train to decrease the focal length. Probably the next thing to look at is what field of view will a given telescope and camera combination give you. In other words, how much of the sky will you see? Now there's lots of really good applications online where you can put in the size of a camera and the focal length of a telescope, and it will give you an idea of how much of the sky, what sort of images can you image. If you've got an iOS device, then we have our own app available on the App Store that will do just this, and it'll help you to choose cameras and look at the kind of objects you'll see well with a given camera and telescope. So what I've got here is a picture of the Horsehead Nebula, and basically we've got a orange rectangle which is showing us the field of view here, and the Horsehead Nebula is nicely framed in this image. And it's taken with, or simulated with, an Atik 420, which is a camera with a relatively small chip size, and the telescope is a ED 80mm telescope f7.5. So it's a relatively short focal length. If we were to move and change to a much longer focal length telescope, something like the Celestron C11, which is 2.7 meter focal length, though used with a 0.6 reducer. If we look then again at what field of view we'll get, you can see we can just about get the horse head in this time. So that is relatively, that's a field of view that is probably slightly too small for imaging too many objects. However, if we've got a Celestron C11 telescope and we want to try and match it with a camera, we should look at maybe choosing a bigger camera from Atik's range or a bigger sensor. So if we choose this time the Atik 4000, we look again and we can see the image scale there is much better. We're nicely capturing both the bright star and the horsehead itself. So by choosing different focal lengths and different size of sensors, we can optimize our setup for imaging different types of object. Right, next I'd like to cover 3 other features you'll often see listed under camera specifications. So we start off with read noise. Now this is the amount of electronic noise that a camera will add to an image while it's being captured. Obviously we want this to be as small as possible, and it's really our job as camera designers and camera manufacturers to make sure that our cameras add the smallest amount possible, and that's what we do. So some of our cameras really are absolutely class leading, and they have read noises around 3 to 4 electrons. Where this becomes particularly useful is if you're imaging with very low sky backgrounds. So this is something like narrowband imaging or imaging at longer focal lengths at very dark sky locations. So here in particular it's important to consider read noise, and that will allow us to get the very best sensitivity from these very weak light sources that we're imaging. Okay, after read noise we have cooling. So all CCD cameras for astro imaging for long exposures will require cooling in order to reduce the thermal noise and hot pixels. Now the amount of cooling a particular chip requires is very dependent on the actual chip it is. So things like the older Kodak sensors needed at least 10 degrees more cooling than the newer Sony sensors. And our cameras will tend to have cooling capacities from between 25 all the way up to about 40 degrees of cooling below ambient. All of our cameras have cooling that is what's required for the type of sensor that is being used for long exposure astro imaging. So whether or not you see a cooling of 25 degrees or a cooling of 45 degrees, it's been optimized for the type of chip that the camera has and optimized for astrophotography. Finally, we have quantum efficiency. Now this is the ability of a sensor to convert a photon into electron, and that's really what the sensor is there to do. If we have a fairly average CCD, it may have a peak quantum efficiency of around 50%. And one of the very best front illuminated Sony sensors will have a quantum efficiency of nearly 80%. Now probably the thing to notice there isn't a huge difference in those two numbers and the impact they'll have on an image if you compare things like pixel size and focal ratio of telescopes. Where quantum efficiency does become particularly important is if you're interested in imaging at the longer wavelengths, things like hydrogen alpha and sulfur, narrowband imaging, or imaging nebula, then the new Sony XView CCDs have very good quantum efficiencies in the longer wavelengths and will give a much stronger image than some of the non-XView sensors. The final attribute of a camera that I think we should consider before purchase would be the price of the camera. In the Atik range, you'll find everything from entry-level cameras right up to the more expensive cameras. It's important to set a budget and then look for a camera that fits that budget and also suits your style of imaging and the telescopes that you would like to use that camera with. And then you can enjoy astrophotography, and it's an absolutely fantastic hobby. Extremely rewarding. You'll be able to take pictures of objects that are way fainter than you can ever see through an eyepiece and detail that you'll never see through an eyepiece. And also you get to share those pictures with friends, family and online. So it's an extremely rewarding hobby. Okay, I hope that you found that useful, and I want to thank you very much for watching.